Hi everybody. So in this video we're going to look at stationary points on a curve, and in particular whether they are a maximum, a minimum, or a point of inflection. And this is all to do with the rate of change of a gradient of a curve. If we look at the maximum, you can see as we travel from the left to the right that the gradient of a curve when x is small is positive. And as we increase our x value, the gradient remains positive but gets smaller, until we get to the stationary point, which is where it turns, and this is where the gradient is 0. So it started off steep, and then less steep, and now equal to 0. So you can see the gradient is getting smaller. And as we go beyond the stationary point, the gradient becomes negative, so it's still decreasing. And I showed you in my previous video that we write the rate of change of a gradient as d squared y over dx squared. So dy by dx describes how the function is changing, whether it's increasing or decreasing, but d squared y over dx squared describes how the gradient is changing. And you can see it's going positive, less positive, 0, and negative. So because this is getting smaller, this is less than 0. And when this is less than 0, you can see that the stationary point is a local maximum. If we look at when the stationary point is a minimum, well, you can see for small values of x that the gradient is negative, and it's quite steep negative. And as x increases, the gradient increases. It's still negative, but it's less steep, until we get to the stationary point where the gradient is 0. And the gradient continues to increase, and now positive and even more steep. So when the rate of change of a gradient, d squared y over dx squared, gets bigger, this is greater than 0, and this is where the stationary point is a minimum. And then we have points of inflection. This is where the gradient before the stationary point is positive, then it becomes 0, and returns to being positive again. So when the second derivative is equal to 0, this could be a point of inflection. And depending on the accuracy, it could also be a maximum or a minimum. We have to consider the points on either side of that stationary point to determine that nature. Okay, so let's move on to some questions. So for example 1, we've been asked to find the stationary points on this curve, and then determine their nature. So the first thing we need to do is we need to differentiate this to find dy by dx. This will be 3x squared plus 2x minus 1. And we know at the stationary point this gradient is 0. So we'll set dy by dx to equal 0, and then we'll solve this equation to find the different x values. We can solve this on our calculator, and we get x is equal to -1 and positive 1/3. So if x is -1, we can find the coordinate of this stationary point by substituting -1 into our equation. So y will equal positive 9, and we can find the other coordinate by substituting in x equals 1/3, and we get approximately y equals 7.81. So to determine the nature of a stationary point at -1 and 9, we need to differentiate this again to find d squared y over dx squared. And this will give us 6x plus 2. Then we substitute in x equals -1. We substitute in this x value. So this will give us -6 plus 2, which is -4. What we say is, because the second derivative is less than 0, this must be a local maximum. Then if we consider the second stationary point at 1/3 and 7.81, we'll substitute this 1/3 into our second derivative. This will be 6 lots of 1/3 plus 2, And this will give us 4. So now, because the second derivative is greater than 0 at this point, this will give us a local minimum. Okay? Let's try another question. Okay, so in this question, we've been asked to find the coordinates of a stationary point of a curve given here, and then to use d squared y over dx squared to show that this is a local minimum. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through a work solution. Okay, so I'll come back if you had a go. So the first thing we'll do is we'll differentiate y with respect to x. So dy by dx will be 4x minus 6. Then we'll set this equal to 0 for our stationary point. So x will equal 3 over 2. Then we'll substitute this value of x into our curve. And this will give us negative 8.5. So at x equals 3 over 2, we can determine the nature of this stationary point. We can find the second derivative by differentiating this, and we get 4. And because this is greater than 0, we know this is a local minimum. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below.